Hey guys, today let's solve Leetcode question 3226. So you're given two positive integer n and k, and you can choose any bit in the binary representation of n that is equal to 1 and change it to 0. If the number of changes needed to make n equal to k, if it's impossible, return -1. So let's take a look at the example. So if we give n equal to 13 and k equal to 4, and we can change the first and the fourth base of n, which is this bits and this bits, and the resulting integers n equal to 0, 1, 0, 0, which is k. Alright, let's take a look at this question. So this is n and this is k. You can choose any bit in n if it's 1, and you can convert it to 0. So I guess many of you will think convert this to integers to a string, and compare each character. But we can solve this question using binary manipulation. So since this is the binary format for these two integers, which is 13 and 4. So the idea I will do is we get the most right significant bit every time. So we compare 1, 0, and we loop through to the left. Right? We compare this one, this one, this one, and we further left over, which is this bit, we have to convert to 0 since there is no bit after this number. So, like how do you get the right significant bit? If you're familiar with bit manipulation, we can do integer, we could do and 1, and we can get the most significant bit on the right side. The idea is like if you do 1, 1, and you use and 1, which you can get 1. That's how you do it. So there's a other consideration. It's like if this n is less than k, we can just return -1. Let's say if we have 0, 1, and you have this is n, and then you have 1, 1, which is k. Since you cannot convert 0 to 1, so there is no way you can do it, let's just return -1. I think that's probably A. And we should have a count to count like how many ones we have to swap to zeros on n to convert this number to k. Alright, let's jump to code. I think it should be really clear. Let's say if n is less than k, we can just return -1. And we have like count equal to 0. Since we don't know the length of k and n, we should do we're using a while loop, while k and n. So whenever which one reaches to 0, like whenever k or n reach to 0, we should stop. So while k and n, and we get the most significant bit on the right side, the n bit, which equal to n and 1. For the same thing, we can do k bit equal to k and 1. So let's do the comparison. If n bit equal to 1 and k bit equal to 0, we can add count to 1. Or if n bit equal to 0 and k bit equal to 1. In this situation, we can just return -1 because we cannot find a way to convert 1 bit to 0. So once we compare the right significant bit for n and k, we should shift n to the right side and assign to n. Do the same thing to k. Alright, after this loop, n, it maybe have some bits left, right? So we have to convert left over bit on n from 1 to 0. So we can do while n, we do the same thing, n bit equal to n and 1. If n bit equal to 1, we can do count plus 1, right? And we shift the n to right side. So if the count is bigger than or equal to 0, we can just return the count. Otherwise, we'll just return -1. I think that's probably it. Let's run it. Okay, let's submit it. You can see the memory is pretty efficient, and the runtime is also efficient too. Alright, let me show the code here. Alright, thanks for watching. Please like and subscribe. Thanks.